Okay, let's continue with example 5. Right, so in example 5 you are asked to find y in terms of x, right, and the given dE is as shown here. Okay, and then you're given also certain initial conditions. When x equals to 0, the value of y is equals to 1. So you know that the solution that you're going to get for this dE after solving it is not the general solution but the particular solution. But before we actually get the particular solution, of course we need to get the general solution first. Right, so as you can see, there are two ways to actually solving this. So let's start with the first way. Right, so again, quite obvious, right, that you need to do variable separable. Alright, so from this line you will have 2e2y dy equals to e dx. Right, so in terms of variable separable method, I'm bringing the terms with the y variable to the left. Alright, whereas the constant e, if I want to bring it to the other side, it is still no problem, but in this example it remains on the right. Okay, so let's start to integrate the left hand side, and because we're integrating it with respect to y, you would have e to y, alright, 2 times half, alright, and on the right will be ex plus c. Okay, so simplify further, you will actually have e power of 2y equals to ex plus c. Alright, so this is the general solution. Okay, so in order for us to find a particular solution, what you need to do is, okay, of course, to put in the initial values, alright, and then find what is c. Alright, so I shall not go into that because you are already quite familiar with it. Now let's do the alternative method. Right, so alternatively, right, you can actually take this approach. Okay, from 2e 2y minus y dy is equals to dx. Alright, so I am still doing variable separable, but I'm actually getting the whole term on the left to the right, such that on the right what's left is just the constant 1. Alright, so integrating again the exponential is no problem, but remember we are integrating with respect to y, so you would actually get e 2y minus 1, alright, divided by 2 equals to x plus c. Alright, simplifying this, you would have e power of 2y minus 1 equals to x plus c. So if you can see this, maybe I use a different color. Alright, this general solution is exactly not exactly, is of the same form of the one that I've just solved in the first method. Alright, just a question for you. Does this constant c, arbitrary constant c, the same as this arbitrary constant c? Definitely not, right? Alright, so in order for us to actually get this arbitrary constant c, again, alright, you look out for the initial conditions. Alright, and as you can see from here, you actually have the same solution, particular solution. Alright, so particular solution. Alright, in this section we are solving the dE of the form, alright, where on the right you actually have terms involving the variable x as well as the variable y. Okay, so as a quick example, alright, in example 6 you are given this differential equation, the dE of this form. Okay, right, so immediately you will realize that the method that we need to use to solve this dE is again variable separable. Okay, so from here what you need to do is separate the variables. right? So you will have y dy and x dx, right? And then, like I said, you cannot leave your working for this step as what you see here, but you need to put in the integral sign, right? So now integrating y with respect to y, you will have half y squared, and on the right side